Okay, what we're going to do in this vodcast is continue our discussion about bonding. And to understand more about ionic bonding, we need to take a look at what we refer to as the octet rule. And as you can probably already tell, this rule is going to involve the number 8 for oct. So what this is going to do is it's going to tell us how atoms give away electrons and take electrons to obtain charges to form ionic bonds. Okay, so the first thing we want to do is take a look at valence electrons. So valence electrons, if you remember from previous units, are the electrons in the outermost shell. So for example, let's say we're talking about magnesium. Magnesium is here, which means it has 3 energy levels. And if you think about it in the old model, that would give it 1, 2, 3 energy levels. Its third energy level contains 2 electrons. And if you remember what block they're in, those 2 electrons are in the s block, or what we refer to as the s orbital. So the valence electrons are the electrons in the outermost shell. So if you're talking about, say, sulfur, sulfur is also in the third energy level, and its valence electrons, it's got 2 in the s orbitals, 1, 2, 3, 4 in the p orbitals, so sulfur has 6 valence electrons. So magnesium's got 2, sulfur's got 6. Aluminum, 2 in the s, 1 in the p, so that's 3. So as you can probably tell, it's easy to determine how many valence electrons an element has by simply knowing what column it's in. So everything in the first column has 1 valence electron, 2 valence electrons, 3, 4, 5, 6, 7, and 8. That's the primary reason that everything in the first column behaves similarly chemically, because they have 1 valence electron to get rid of. Everything in the second column behaves chemically similarly also, because everything in the second column has 2 valence electrons. The transition metals get a little bit trickier, because if you remember, when you go into the d orbitals here, you go down a level. So these electrons here are going to be in the third energy level. So we're not going to talk much about the transition metals when we talk about valence electrons. We're going to confine our discussion to the group A elements, column 1, 2, 3, 4, 5, 6, 7, 8A, not the transition metals. We'll still use those in bonding, but we're not going to use the same convention that we use with valence electrons. Okay, so let's talk about the octet rule. The octet rule says that atoms want a full outer shell. And to get a full outer shell, atoms need 8 valence electrons. So if we go back and look at magnesium here, we know that magnesium has 3 energy levels, the first, second, and the third. So magnesium can get a full outer shell 2 ways. It can add 6 electrons to its third energy level, or it can get rid of 2 electrons in that third energy level. Then its second energy level would have 8 electrons. So if we're looking at magnesium, and let's just draw the Bohr model. We have 1, 2, 3 energy levels, 2 electrons in the first, 1, 2, 3, 4, 5, 6, 7, and then 8 in the second, and then we have 2 electrons in the third. So magnesium can either gain 6, or if it got rid of those 2 electrons, now it's got 8 electrons in its outermost shell. So magnesium will get rid of those 2 valence electrons to obtain an octet, or a full outer shell. When it gets rid of those 2 electrons, as we talked about in a previous unit, it's going to obtain a 2+ charge. Chlorine, on the other hand, is right here. So its third energy level, it has 7 valence electrons. So chlorine would either need to get rid of 7 or gain 1. And as you can probably tell, atoms want to do the least amount of work. In other words, they want to get rid of or gain the smallest number of electrons. So chlorine isn't going to want to get rid of 7. It would rather gain 1 electron to obtain that octet. When it gains that 1 electron, it would obtain a 1 minus charge. So if we look at our periodic table again, what we're going to see is things in the first column would want to get rid of one electron. That would give them a +1 charge. Things in the second column would get rid of 2 electrons. That gives them a 2+ charge. Things in the third column, +3. We're going to skip that fourth column. We'll talk about that when we talk about covalent bonding. Things in that column are going to want to gain 3 electrons, so -3. Those will gain 2. Those will gain 1. The noble gases already have 8 electrons in their outermost shell. All of them have 2 in the S's, 6 in the P's. So they're not going to gain or lose electrons. Noble gases are called noble because they don't interact with the other elements. They have an octet already. So earlier when we talked about writing formulas, we designated these charges for the columns, +1, +2, +3, etc. Now you can see where those charges come from. Things in the first column get rid of 1 electron, things in the second column get rid of 2, etc. Okay, so when we start talking about bonding, we use electron configurations to illustrate where those electrons go. So for example, magnesium, we said its electron configuration is 1s2, 2s2, 2p6, 3s2. So if we were looking at its noble gas configuration, it would be neon 3s2, and those are the valence electrons. So again, to gain an octet, neon is going to get rid of those 2 electrons from the 3s orbital. Aluminum's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p1. So you can see the outermost shell, 3 valence electrons. On the other hand, oxygen, 1s2, 2s2, 2p4, its valence electrons now are there, the 6 valence electrons. So oxygen is going to want to gain 2 electrons into the 2p orbital to make that 2p6. And then nitrogen, we would have 1s2, 2s2, 2p3. Again, to gain 8 valence electrons, it's going to gain 3 electrons into that p orbital to obtain a 3- charge. Okay, as we start talking about bonding, the important thing to remember from this vodcast is these charges. Things in the first column would have a +1 charge for getting rid of an electron. Things in the 7th column would have a -1 charge from gaining an electron. And as we talk about ionic bonding, compounds will come together based on those charges.